Okay, poll. There are about 2 million characters, letters or numbers, in your Campbell Essential Biology with Physiology textbook that I assigned you guys for this semester. Would you be able to copy every letter, every number in your textbook by hand 500 times within a reasonable time frame without making a single mistake? Yay or nay? I know you guys aren't going to be able to participate in this discussion for your class. You can see what last semester said. Majority said no, about 84%. Last semester I had about 16% be some really competent believers that they were able to do that. Just in a lecture, I make a mistake. When I lecture you guys, when I write on the board, I can make a mistake. It happens. I'm constantly erasing what I'm writing. That's not even going to be 100 characters and numbers. You're asking me to do this 2 million times 500? No, forget it. There's no way that I'm going to be able to do that. I'm going to make a mistake. So this is what we're asking ourselves to do to our genetic material. We're, replicating DNA in the S phase of the cell cycle and then undergoing cellular reproduction, whether that would be mitosis for any somatic cell or meiosis for our gametes, and then going through the cell cycle again and doing that all over again, and then asking our cell to continue doing that. Our skin cells are great examples that they do this quite frequently, and so mistakes can and will happen. You're asking millions of nucleotides to be perfectly coded. Mistakes will happen. So DNA replication in itself is pretty accurate. The process is pretty accurate in itself. The accuracy would be like doing what I just asked you, copying every single letter, number 500 times, and just writing one of those incorrectly. So DNA replication makes one error. Maybe it put an A instead of a T. Maybe it put a T instead of a C. It makes just one error in those bases in every 1 billion characters. DNA replication is efficient in not getting any errors by these 3 different categories. Proofreading is one of them. Your enzyme DNA polymerase is the one that's going to lay out those new nucleotide monomers. They actually check their work. They proofread their work. They're like, did I do that right? Yes. And you saw how fast that they were doing that. So this is a very fast process. Did I lay that correct base with that parent strand? So this is proofreading. DNA polymerase performs this function. Mismatch repair is going to fix any mispaired bases after DNA replication has occurred. This is called mismatch repair. I actually have an image to show you this. So if there's a mismatching, let's see, where's my pointer? So let's say that these bases were added and they are the incorrect bases. They were not the right ones to add here at this time. So that's, DNA polymerase made an error and it didn't catch it in its proofreading. Well, there's a certain dimer formation that forms. I won't test you guys on this exact technique, but because of this dimer formation, a mismatch repair comes in and fixes it, takes it out. It makes a new area that's going to lay out the correct basis, and it's going to match the correct complement strand to its parent. DNA ligase comes in and seals that up. So that's called mismatch repair. The third process that's going to help with the accuracy of DNA replication is various enzymes that are going to be involved in DNA damage repair pathways. Basically, they just correct the damaged DNA throughout the cell cycle. So it doesn't have to happen during DNA replication like proofreading. It doesn't have to happen straight after DNA replication like that mismatch repair. It's just basic DNA and various DNA damage repair pathways that different enzymes are involved in that I won't go into detail in this lecture. So the final pairing error in DNA replication is then 1 in a billion characters. So that's very good, a very efficient process. Let me see. I do want to point out, though, that we do have an error forming, 1 in a billion, but that's still an error that can happen. This is going to be paving the way for something that I'm going to teach you in future lectures called mutations. And that's going to be very important when we hit up adaptation and evolution.